Hello guys, in this video let us discuss about open as well as closed pipe. If you become perfect with open pipe, automatically you will get closed pipe with a small differences. Okay, let us compare and read so that it will be very easy to understand as well as prepare. Now let's start. First, open pipe. So you have to write the definition of open pipe. The word itself is saying answer. The pipe, organ pipe, which is open at both ends, is called open pipe. Right? Definition is easy, no need to by heart. Open at both ends. Okay. Now next, as usual, you have to write the formation of stationary waves in open pipe. So before that, in a last video, I said it is important to understand the question. Underline the main point. Here you see, explain the formation of stationary waves in. Here he will give open pipe. And here he will give closed pipe. Underline that words. And in last video, stretched strings. Okay. Now let us write the formation. So now first what you will do? Send a wave inside open pipe. Okay, what you did? You sent a wave inside the open pipe. Now what happened? This wave reflects at other end of the pipe. This wave reflects at other end of pipe. Right? Now if this is the pipe open at both ends. Now we sent a wave, first point. We call it as incident wave. At other end, it reflects. Okay? At other end, it reflects. In such a way. This we call reflected wave. Now I can write the incident wave and reflected wave, or simply you can write both waves. Okay, the incident and reflected waves, how they are traveling. This is the direction of incident wave and this is the direction of reflected wave, opposite to each other. The incident wave and reflected wave traveling opposite to each other. Superimpose and produces stationary waves. And produces stationary waves, right? Okay. If you understand the concept, it will be easy to learn. The incident wave, reflected wave, traveling in opposite direction, superimpose on each other to produce stationary waves. Now see, at open end, displacement is maximum. So we get antinodes at open end. Antinodes are formed at open ends. As displacement is maximum, antinodes are formed at open ends. Now, let us go for the explanation. Okay. First, consider open pipe of length L. Okay, the same I'm drawing here. Here if you don't draw also doesn't matter, but here you have to draw. Diagram carries 1 mark. Never neglect the diagram. Prepare the diagram in a very good manner. Draw the diagram with pencil in the exam. So now I considered a open pipe of length L. Right? At open ends what we said? Antinodes will form. Right? Now the distance between antinode and antinode will be half of the wavelength. So for the first harmonic I am writing lambda 1 by 2. Okay. Next point what I have to write? The length of air column is equal to half of the wavelength lambda by 2. Now I will write L is equal to lambda 1 by 2. Now cross multiplication, what happens? Lambda 1 equal to 2 I am sending to this side. 2L. Okay. Now we know V equal to nu lambda, no? From that we will write the frequency. So V is equal to nu lambda formula we know, no. So nu equal to V by lambda we will bring to this side. It comes into denominator. So we are writing as lambda 1. So I will substitute lambda 1. So nu equal to V by what is lambda 1? 2L. Right? V by 2L. Okay. Now next. This we call it as fundamental. Here for first harmonic I am writing nu 1 also. Fundamental frequency, or this can also be called as first harmonic. Right? Now next. Again second harmonic. Second point, first point completed. Now the wave pattern will be in such a way. The incident wave. So the reflected wave. Right? Opposite direction. Here attends antinode, here antinode. Now calculate the distance between antinode and antinode. Second harmonic, no, I will write it as lambda 2 by 2. The same distance. Lambda 2 by 2. Here to here lambda 2 by 2. Here to here lambda 2 by 2. So the total length what we said? L, open pipe length. So L equal to how many lambda by 2s are there? Lambda by 2 plus lambda by 2. How many are there? 2 are there. 2 lambda 2 by 2. Now we want lambda 2. This 2 will go into the numerator and this 2 will come into the denominator. Next what you will do? Frequency. Write it as nu 2. What is the formula? V by lambda. Instead of lambda, I am writing lambda 2. So, V by, what is lambda 2? 2L by 2. Here we got now 2L by 2. Now, this 2 comes in upward direction, numerator 2 of this 2. V by 2L as it is I wrote. V by 2L. Now, this came here. Now, nu 2 of what is V by 2L? Nu 1. I am substituting, right? Nu 1, right? I substituted nu 1. Now next, third harmonic. Let us draw that. Loops are increasing. See here, no loop. Here, one loop game. Just for your idea, I am saying logically, you have to remember in such a way. Now we will get 2 loops. Okay. So first you draw loops, then you keep the arrow marks. It will be easy. First, incident wave. Just follow this and keep it. Reflected wave. Keep the arrows. Right? 2 loops. Maximum amplitude, antinode. Okay? So again, what you will take distance between antinode to antinode. Again, antinode to antinode. Again, antinode to antinode. Third harmonic, no, the total length is L. Third harmonic, no, 3 I will place. Lambda 3 by 2. Lambda 3 by 2. Lambda 3 by 2. Right? Now L. How many lambda 3 by 2s are there? 3 lambda 3s by 2 are there. I added all this. So what I will get? Same, no? 3 lambda 3 by 2. But what I want? Lambda 3 I want. 2 will come into the numerator. 3 will come into the denominator. Then again what I will write? Frequency. I forget it to say. This we call it as second harmonic or first overtone. Right? Now, come to this. Frequency nu 3 I will write V by lambda 3. V by what is lambda 3? 2L by 3. This 3 comes up V by 2L. So what is V by 2L? As usual, nu 1. Here we derived, no? That only I am substituting. Nu 1. Right? Nu 1. So this we call it as third harmonic or second overtone. In such a way we can go on doing. Okay. So in such a way you can practice for 4, 5, 6. Just go on increasing the number of loops. Again 3 loops, 4 loops. In such a way you practice. So harmonic ratio for for open pipe. How you got? Nu 1 is to 2, nu 2 is to 3, nu 1. 3, nu 1, so on. That is equal to 1 is to 2 is to all nu 1s, no. 3, so on. So the harmonic ratio for open pipe is 1 is to 2 is to 3, so on. So this is about open pipe. Now see, let us move to closed pipe. Here you read whether he gave closed pipe or open pipe or stretched strings. Depending upon your answer must be there. First what you will write? Definition. Okay? What you will write? Pipe which is open at one end, closed at other end. Just note down the small differences. Here open at both ends, no. Here open at both ends. But here open at one end, closed at other end is called closed pipe. Next what you will write? Formation. Right? What you wrote here? The same to same I am writing here. Right? First, send a wave inside. Instead of open, I will use closed pipe. Right? This wave reflects at other end of pipe, right? Next, incident wave and reflected wave. Traveling opposite to each other, opposite to each other. What happens? Superimpose on each other and produces stationary waves. Next point here, what we wrote, antinodes are formed at open ends. As usual, antinode will be at open end. But now here, how will be the tube I said? One side, it will be open. Other side, it will be closed. Now this is incident wave and this is reflected wave, right? Antinode is formed at open end. So at closed end, amplitude is becoming 0 or displacement is 0. So node is formed. Okay. So what you will write? Antinode is formed at open end. And node is formed at closed end. Right? Same. See. Same to same. But small difference. What here? At both ends open. Antinodes will form. But at one end it is closed. So node forms. Right? Now next. As usual. Explanation. Consider instead of open what I will write? Closed pipe of length L. Now here the length of air column is equal to what we have to write. Now see what distance you will take. Now this is incident wave and this is reflected wave, antinode node. So here you are considering the distance between antinode and node. Antinode and node. So what is the distance between antinode and node? Just remember first harmonic. No, I will write lambda. Lambda by 4. This difference you have to know. Here between two antinodes or two nodes. Lambda by 2. Between antinode and node, it will be lambda by 4. So it is quarter of wavelength. Can I write? Again. 1/4 of wavelength. If you don't write also doesn't matter, but you write LA in correct manner. Lambda 1 by 4. Again what I will do? Lambda 1 4. It will come to this side. It becomes 4L. Instead C. Instead of 2L, you got 4L. Next what you will write? Frequency. Nu 1. What is the formula? V by lambda 1. V by instead of lambda 1, 4L. This we call it as fundamental frequency or first harmonic. Clear? Now next, what you will do? Second harmonic or first overtone. Again, closed pipe. One loop you will get. First you draw these loops, then place the arrows. Incident wave, right? Reflected wave. Okay? Antinode, zero displacement node, antinode node. In textbooks what he did, antinode distance, again antinode node. For your calculation it will be problem for you people. So you just take the distance, the total length is L, no? Just take the distance as antinode node, node antinode, antinode node. What is the distance between antinode and node? Lambda by 4, no. Second harmonic, so lambda 2 by 4, lambda 2 by 4, lambda 2 by 4. Now L how we will write? Now see. Here only 2 you got, here you got 3. A small difference. Here only 2 you got, here 3. Lambda 2 by 4 plus lambda 2 by 4 plus lambda 2 by 4. What you will get? 3 lambda 2 by 4. But you want lambda 2, 4 will come in denominator, 3 will go in, 4 will come in numerator, 3 will go in denominator. 4L by 3. Next what you will write? Frequency. What is frequency? Nu 2 is equal to V by lambda 2. V by what is lambda 2 here? 4L by 3. 3 will come up. 3 of V by 4L as it is I am writing. But what is V by 4L? Here we wrote. Nu 1. I am substituting nu 1 here. So, nu 2 equal to 3 nu 1. Similarly, this we call it as second harmonic or first overtone. Right? The third harmonic. So, what I said? As harmonic increases, loops increases. 2 loops you will get. Right? Draw loops in a correct manner. Then keep the arrows for incident and reflected wave. Diagram carries marks. So diagrams are compulsory. So antinode, node, antinode. This one node, dot I am keeping, you see. Node, antinode, node. Again what you will do? Distance between antinode node, node, antinode, antinode node, node, antinode, antinode node. So, lambda 3 by 4, third harmonic, no? Lambda 3 by 4, lambda 3 by 4, lambda 3 by 4, lambda 3 by 4. So, L is equal to lambda 3 by 4 plus 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 lambda 3 by 4. How many lambda 3 by 4s you got? 5 lambda 3 by 4s you got. So now lambda 3 becomes 4 will go into numerator, L 5 will come into denominator. Next what you will write? Frequency, no? Nu 3, V by lambda 3. V by what is lambda 3? 4L by 5. What is lambda 3? 4L by 5. 5 will come up. Nu 3 equal to 5. V by 4L. What is V by 4L? Nothing but nu 1. Right? Now here 3 nu 1 you got. 5 nu 1. Right? So now this we call it as third harmonic or second overtone. So harmonic ratio for closed pipe. Nu 1 is to. Next what I got? 3 nu 1 is to. Next what I got? 5 nu 1, so on. That is equal to 1 is to 3 is to 5, so on. Now see harmonic ratios. Here in open pipe 1, 2, 3, 4, so on. Here 1, 3, 5, 7, so on we will get. Means here we are getting whole numbers, natural numbers as harmonic ratio. Here we are getting odd numbers 1, 3, 5, 7, 9, 11, so on. In such a way we will get. Here odd harmonics we got. So by doing this you see. So compare in such a way. Right? And just first be perfect with open pipe and then with a comparison where the changes are taking place, you just check and do that changes and go on. Procedure is same, but here lambda by 2, here lambda by 4. You have to remember that. Here we will get the ratio as 1, 2, 3 and here we will get the ratio as odd number ratio. That is 1, 3, 5. So If you learn open pipe perfectly, you will get closed pipe because of same procedure, same method, with a small difference that in open pipe you are taking distance between antinode and antinode, that is lambda by 2. In closed pipe you are taking the distance between antinode and node, that is lambda by 4. If you can understand and remember these distances perfectly, 100%, you will get full marks for this long answer question. If you like my video, share it, subscribe it. Thank you for watching my video. Yours, Reshma Physics.